Again, welcome to Calculus course. In these lectures, we're going to discuss about functions. This is our Unit 1, lecture number 4. So our main objective is to decide whether the relationship between two variables is a function. Also, we are going to learn how to find the domains and the ranges of functions. Also, how to use function notation and also how to evaluate functions. So first here we said that in many common relationship between two variables, the value of one of the variable depends on the value of other variables. We have so many applications on this concept in statistics. For example, we can try to find a correlation value, which is we want to quantify the relationship between two variables. So we find the R value, which is called the PSC correlation. And in this case, we want to know if there's a relationship between two variables. Also, if there's a relationship, we can use something called the regression analysis to predict a future value. This means these two variables, one will be the independent variable and one will be the dependent variable. For example, we want to find out whether if a company spend more money on advertisement, will the company earn more revenue? So we want to find out if there's a relationship between revenue generated by the company and also the expenses there's on advertisement. In this case, the advertisement expenses will be the independent variable, and then revenue generated will be the dependent variable. So in this example we have here, they say consider the relationship between the total revenue R and the sale of X units of a product sold for $1.25 per unit. Now, this relationship can be expressed by the equation R equal to 1.25x because every X is sold for $1.25. So here we can say there's a relationship between the number of products sold and the revenue generated. So let's go to the definitions. First of all, we're going to find out if there's a relationship between two variables. Then secondly, we want to know that that relationship creates a function. So first we said in this equation, the value of R, which is the revenue, depends on the choice of X. So the more X product we sell, the more revenue we're going to generate, which is revenue equal to 1.25x. So in this case, we call the X as independent variable because X will determine the R. The R will be called the dependent variable. And in some textbooks, the dependent variable can be called the output variable, and independent variable will be the input variable. So next we go to the function. So a function is a relationship between two variables such that to each value of the independent variable, there corresponds exactly only one value of the dependent variable. And what we mean to say here is that if I have an input, let's say $10, I want my revenue output should be generated, only one value should be generated, which let's say is $1,000. Now, if I have input of $10 and it can generate two outputs, let's say 1,000 and 2,000 from only one input value, then it's not a function. The relationship is not a function. So we say a function is a relationship between two variables such that to each value of the independent variable, the input variable, we are going to generate only one value for the dependent variable. So now if we have one independent variable and we generate two dependent variables, it's not a function. But if we have two independent variable and we still generate one independent variable, it's still a function. It's a function. So the domain of the function is normally the set of all the values of the independent variable. In this case, we say the X values. Then the range will be the R values. So the range of a function is the set of all values taken on by the dependent variable. So we have a diagram to explain. So here, for example, we have a function as a system. So first we need an input. So our input will be the domain. So a set of values of the input is called a domain. And here we represent it as X. Then the output will be the range, which we represent as Y. So if we have an input, we want to generate only one output. If we have different two inputs, we want to generate also two outputs. So for instance, here we have equation y equal to 4x squared plus 3. This is a function because any x value we have, we are going to generate only one y value. So x is our independent variable. If we have one independent variable, we are going to generate one dependent variable, which is the y. So this describes y as a function of x. X is again the independent variable, y is the dependent variable. So for this function x, again, is the independent variable, and also y is the dependent variable. Now we want to decide whether each equation defined as a function of x. So we have x plus y equal to 1, x squared plus y squared equal to 1, x squared plus y equal to 2, then x plus y squared equal to 1. So we start with the first one, and we are going to decide. So the first one, we can say that if we have one x value, we are going to generate only one y value. So x plus y equal to 1 is like writing y equal to 1 minus x. So we have x plus y equal to 1, which means y equal to 1 minus x. So any one x value, we are going to generate only one y value. So this is a function of x. So the original function is x plus y equal to 1. We rewrite it as y equal to 1 minus x. So when we test it, we can find out that y is a function of x because each value of x generates only one y value. Now let's look at the b. The b, we have x squared plus y squared equal to 1. So we can rewrite it as y equal to plus or minus square root of 1 minus x squared. Because here we can transform the equation by writing y squared equal to 1 minus x squared. When the square crosses the equal sign, it becomes a square root. And also the square can give us either positive or negative. So this is not a function. The reason why, because if we have a value of x to be 2, we can generate a positive or negative answer of the equation. So we may have at least two values for y, just for only one x value. So that's not a function. We say some values of x will determine two values of y. So it's not a function. Now let's look at C. X squared plus y equal to 1. We can rewrite it as y equal to 1. Xy is plus, so when it crosses the equal sign, it's going to be minus. So we have y equal to 1 minus x squared. This is a function because any x value we get, we are going to generate only one y value. And the next one, we have x plus y squared equal to 1. So y will give us 1 minus x square root, positive or negative. So again, this is not a function. The reason is because one x value can generate two y values for us sometimes. So it's not a function. So we should note that the equation that assigns two values, plus or minus, to the dependent variable for a given value of the independent variable do not define the functions of x. Because as we said earlier, if we have x value, we want only one independent or input variable value should give us only one output or y value. But when we have plus or minus, it means we can generate two values for y. So the first equation, x plus y equal to 1, is a function. The second equation was a circle. It's not a function. The third is a parabola. is a function. And also x squared plus y squared equal to 1 is not a function. Normally, we can use something we call the vertical line test. When you have a function as a graph, you can draw a vertical line in any direction, vertical line. When the line touches the graph twice, then it's not a function. Because this means at that value, at that very particular x value, we can get 2y value. That's why it touches twice. Example would be the D. Here we can see that if I draw any vertical straight line, I'm going to get 2 touches. So this is not a function. Because at -1, when s is -1, I'm going to generate positive and negative value for y, 2 values. A circle also is not a function because any vertical line will touch the function twice. So it's not a function, which means at any particular s value, we are going to generate 2 y values. So that's what we said. The vertical line test states that if every vertical line intersects the graph of an equation at most 1, then the equation defines y as a function of x at most 1. So if it's more than 1, 2, or more, then it's not a function. So next we go to the domain and range of a function. As we said, the domain of a function is a set of x values, or the independent variable values. The range of a function, again, is a set of the y values. So here we say the domain of a function may be described explicitly, or it may be implied by an equation used to define the function. So for example, the function given as y equal to 1 divided by x squared minus 4 has an implied domain that consists of all real numbers s except s equal to plus or minus 2. When we look at this equation, we know that if s is 2, we cannot divide a value by 0. It's undefined, there's error. So which means in order to have a value of y, x shouldn't be positive or negative 2. So the domain values, it can be any set of values from negative infinity to positive infinity, except that the value cannot be negative or positive 2. If it's negative or positive 2, we cannot get any value for y. Because any value divided by 0, there's no answer for y. So yeah, they say we should find the domain and range of each of these functions. So y equal to square root of s minus 1. Now, we cannot also have a square root of negative value. So from this equation, I will say all the set of x domain will be any value that is greater than 1, or that is at least 1, because square root of 0 is 0. So we may have the answer. Solution of square root of s minus 1 is not defined for x minus 1 less than 0. Because again, we can't find a square root of a negative value. So the only way we can get a negative value is when x is less than, again, 0. That is for x less than 1. Oh, sorry, less than 1. Yeah, because if it's 1, 1 minus 1 is 0. Square root of 0 is 0. Only one answer. So here we can have the domain of the function. It should be any value that is greater than or equal to 1. Or we can say from 1 to infinity, from 1 to any value. So the value has to be at least 1 or greater than 1. Because square root, we cannot have a negative value. Division also have to come to our mind. We can't divide by 0. So that's why the previous, we have s squared minus 2. The answer cannot be, s squared minus 4. The answer cannot be 2, positive 2 or negative 2, because that will give us 4. Positive 2 square will give us 4. 4 minus 4 is 0. Negative 2 square will still give us positive 4. 4 minus 4 is still 0. So here they say to find the range, we need to observe that square root of s minus 1 is never negative. It's never negative, because if it's negative and there's no answer, square root of a negative value is undefined. And also, moreover, as S takes on the various values in the domain, Y also takes on non-negative values. So the range is also the interval Y should be greater than or equal to 0. So it will be from 0 to infinity also. Now, because this function is defined as for x less than 1 and for x greater than or equal to 1, the domain is a set of real numbers. And normally we call this function the piecewise defined function. The piecewise, that's our second example. This is called the piecewise defined function. Here we have 1 minus x when s is less than 1, and square root of s minus 1 when s is greater than or equal to 1. So the first part, again, we are going to get any real numbers can be the domain. Any real numbers of x can be the domain. So we said that if s is greater than or equal to 1, then this will work because we don't have no negative value. Now, if s is less than 1, this also will work. And actually, this will work for any value. So we can see the graph, the first y equal to square root of s minus 1. It's our first graph here. Then the linear is y equal to 1 minus x. And next we say a function is one-to-one when to each value of the dependent variable in the range they correspond to exactly one value of the independent variable in the domain. So a one-to-one function means every dependent variable, one value will generate one dependent variable value, so 1. So geometrically, a function is one-to-one when every horizontal line intersects the graph of the function at most once. So every one x value will generate one y value. Then we have one-to-one function. So this geometrical interpretation is a horizontal line test for one-to-one function. So a graph that represents a one-to-one function must satisfy both the vertical line test and also the horizontal line test. The next section is a function notation. Here we're going to use f at x as our function notation. So for example, I have an equation y equal to 1 minus s over 2. And we normally write the y as f at x, which means at any given value of x, we can be able to find y, or f at s. So f at 1 will be 1 minus 1 over 2, which will give me 0. F at 2 will be 1 minus 2. I substitute x with 2, which will give me negative half. So an example we have here, for instance, if s equal to 3, then f at 3 will give us 1 minus s is 3, so we substitute with 3 over 2, which gives us negative 2 over 2, and they will cancel each other, we get negative 1. So here we say the value of f at 3 is called a function value, and also it lies in the range of the function f. This means that we may have a point 3 and f at 3, which is 3 and negative 1, lies on the graph of the function. Now there's another section here. This is also a function notation example. Let's say we have f at s equal to s squared plus 7. And the example here says we should evaluate each expression. The first expression will be f at x plus dx, or delta x. Then b, we are going to find f at s plus ds minus f at s over dx. This is the formula we are going to use to find the derivative of a function. So let's start. So first, we are going to substitute x with x plus dx. So we have f at s plus ds will give me, now it will give me s plus ds all square. Because anyway, I see f at s, I substitute with s plus dx. So here we can remove the parentheses, perfect square. So we get s squared plus 2s dx plus dx squared plus 7. Now b, we are going to find f at x ds minus f at s divided by dx. So first we know f at s dx, which we get to be s plus dx all squared plus 7 minus f at s. So f at s is the same as s squared plus 7, because in the question we said f at s equal to s squared plus 7, all divided by dx. So we can solve this problem by opening the parentheses. We get s squared plus 2s ds plus ds squared. And then here we have the plus 7, then minus s squared, then minus 7. Plus 7 minus 7 will cancel each other. Minus s squared plus s squared also will cancel each other. So we get 2s dx plus ds squared dx. Now ds is common, so we can take it out and then we cancel it. So we have 2s plus dx. The s we make sure it's not equal to 0. So this will be the conclusion of our lectures on functions. The main concept of this, or the objective of these lectures again, is to understand what is a function. And here we said anytime we have a relationship between two variables, it can be a function. Sometimes it won't be a function. It will be a function only if one input generates only one output, or if one independent variable value generates only one dependent variable value. Other than that, it's not a function. Also, we went through what is a domain and ranges and how to find them, and also a function notation. We're going to see more in our next lectures, and also how to evaluate functions. So again, thank you for your time and wish you the best.